Next one. Negative 4 plus 6i squared, which is pretty much the same thing as that. Negative 4 plus 6i squared, but this gives me an opportunity to remind you that you just can't square each piece. Negative 4 plus 6i squared is the same thing as negative 4 plus 6i times negative 4 plus 6i. And you're having to full again. See if you can full and combine your middle terms all in one step. Negative 4, 16. It'll be minus 24 and minus 24, which will give you minus 48i. Good. Good. Plus 36i squared, but again we know I squared is negative 1. So close. 16 minus 48i, this will be minus 36, so instead of plus 20 it'll be negative 20. Questions? That's pretty easy. Just again, which also you've got a smaller class this year to where y'all might have been the ones that understood it. I don't know. Anywhere you have an I squared, put negative 1. That's it. Y'all didn't get it last year. Let's see. Rationalize the denominators. This is all this means. The bottom of a fraction, we don't want i's and we don't want square roots. If you have two terms down there, it's a little bit more difficult, not a lot. All you got to do, it says rationalize the denominator. All you do, multiply by the conjugate. To get rid of, and what conjugates are? The conjugate of 2 minus 3i, change the minus to a plus, is 2 plus 3i. So all you got to do to get rid of an I on the bottom, and again, really technically what you're doing here, you're actually dividing those. 3 plus 5i divided by 2 minus 3i, and we're going to get a single complex number. 3 plus 5i, 2 minus 3i, is that right? So we're going to multiply top and bottom, and make sure that you do full it. Multiply top and bottom by 2 plus 3i. The reason this is legal is, yeah, these would cross out. You're multiplying by the same thing. That's like taking 1/2 and multiply top and bottom by 3. It's 3/6. It's the same thing. That's legal. So on top, let's see if we can do this. We got 2 and 3 is 6. You got plus 9i, plus 10i, plus 19i, isn't that right? And then plus 15i squared. Let's go ahead and change that to minus 15. Plus 15i squared would be minus 15. On bottom, 2 times 2 is 4. Positive 6i, negative 6i. Don't have to put them. That's the whole purpose of this. Negative 3i times positive 3i is negative 9i squared, which is positive 9. I's are gone on bottom. That was the whole purpose. So on top, 6 minus 15, negative 9 plus 19i over 13, which split that. Write it as a this is not written in basic complex number form. Write negative 9/13 plus 19/13 I. So that's it. It's now in complex form. You have a real part, you have an imaginary part. And again, technically what we just did is divided those two things by multiplying by the conjugate. Okay, now actually splitting them. We're nearly done with this first section. Square roots of a negative can be written as an imaginary number by splitting the root into stuff times the square root of negative 1, which equals stuff times I, because square root of negative 1 is I. Let me show you what I mean. Square root of negative 12. We know that we cannot have the square root of negative 12. And the whole time, the reason we've been saying we can't have a square root of a negative is because it's not real. But we're not dealing with real anymore. We're dealing with complex numbers. We're dealing with imaginary numbers. So even though this isn't real, it still exists. You do the square root of 12 times the square root of negative 1. That would be my first split, because I know that I can write that as the square root of 12 times I. But I want to go a step further. Square root of 12, let me remind you how to do this. The square root of 12, you can split into square roots that you know. I know the square root of 4. I know the square root of 9. I know the square root of 16. That's my first 3 roots I know. Take the square root of 12 and split it into stuff that you know. Split it first, and then instead of trying to do it in your head. Square root of 4 times the square root of 3 is the square root of 12. So this is 2. Move the I over here and write it next to it. 2 times I times the square root of 3 is the square root of negative 12. Yeah. Like I said, most of what we do this year we did last year. It's just hopefully this time through it clicks a little bit better. Yeah, it should. Because, yeah. I agree. Okay, next problem. You got 2 plus the square root of negative 5 over 4. 2 plus the square root of negative 5 over 4. Again, that's a complex number. And do you notice that this looks a lot like your quadratic formula? And that's where we're going with these. Square root of negative 5 you can split into, I'm going to do it down here. Square root of negative 5 is the square root of 5 times square root of negative 1. Make sense? And this is I. So we have 2 plus, what? I root 5 over 4. Yeah, I'm going to go one step further with it. 2 over 4, that's a half, plus I root 5 over 4, which if you can write it like this. I'm going to put I root 5 over 4, but you can also get comfortable with this. Something over 4 is the same thing as 1/4 I root 5. You can write that either way. Dividing by 4, that's kind of like having a 1 out there, 1 I. Break that, pull the 1/4 out front, and you can write that as 1/4 I root 5. Yeah. Division by 3 is a third. Dividing by 3 is the same thing as taking a third. Dividing by 4 here is the same thing as taking a fourth. Yeah, you can pull out. Next problem. 3 plus the square root of negative 16 times negative 4 minus square root of negative 9. What I would do before I started this problem is go ahead and change these to I stuff, because these are going to be pretty easy. So you got 3 plus the square root of negative 16 is the square root of 16 times square root of negative 1. What is that? 4i. Times negative 4 minus square root of 9, square root of negative 1 is 3i. You okay there? Square root of negative 9, it looks like a cube. So that's the square root of 9 times the square root of negative 1, which is 3 times I. And then, same thing as before, 3 times negative 4 is negative 12. 3 times negative 3i is negative 9i. 4 times negative 4i is negative 16i. And negative 12i squared. I would get into the habit of doing this. Combine those, and at the same time, go ahead and combine these. So you got negative 25i. Negative 12, and this will be a plus 12, which does cancel. So negative 25i. Pure imaginary. You see why they call it pure imaginary? Because you have no real. Yeah. They hardly ever say pure real, though. They just say real. So yeah, a real number can't have, I guess that's, yeah, can't have an imaginary part. So pure imaginary doesn't have a real